Alright, today we are going to start talking about proofs. Okay, we're going to start talking about proofs. To start, okay, we're going to do algebraic proofs. So this is just going to be solving equations and then writing down a reason for each step. Okay, so to introduce us to the idea of proofs. So first, we need to make a list of the different properties that we can use in our proofs. Okay, so we know all of these. We've seen all of these before. Okay, we're just going to put some notation to them. So the addition property of equality just says, well, if I have an equation, right? So we can say A equals B. Right? Two things are equal to each other. The addition property just says I can add the same thing to both sides of the equation. So I can add C to both sides of the equation. Okay. The subtraction property, same idea. Right? If I have some equation, then I can subtract the same thing from both sides of the equation. Multiplication property. If I have an equation, then I can multiply both sides of the equation by the same thing. Right? So we can say A times C, B times C. The division property. Again, same idea. If I have some equation, then I can divide both sides of the equation by the same thing. The distributive property. You guys know how the distributive property works, right? If I've got A times some quantity B plus C, then I can just distribute that through and say that's equal to AB plus AC. Substitution property. Okay, again, this is something you've worked with as well. Okay, if I know that two things are equal to each other, then A can be replaced by B in any expression or equation. Right? So you use these every single time you solve an equation. Right? You can add, subtract, multiply, or divide both sides of an equation by the same thing. You can distribute, and if you know two things are equal, you can substitute them in place of one another in an equation. The last three, okay, these ones seem almost too obvious, okay, but these will actually end up being useful when we get into geometric proofs, okay. The reflexive property just says if I have some number, A, well, that's equal to itself, okay. But, right, 2 equals 2, okay. It seems almost pointless to even write that down, but that will actually end up being useful later on. The symmetric property just says if I have some equation, I can flip things across an equal sign. If A equals B, then B equals A. And then the last one on here, the transitive property, says if I know that two things are equal to the same thing. So if I say that A equals B and B equals C, okay, so both A and C are equal to B, then they're equal to each other. Right? Another way of saying that would be like, well, if I'm the same height as Gage, Gage is the same height as Gavin, then I'm the same height as Gavin. Right? That's the transitive property. Right? Any questions so far on these properties? Okay, so then down here, okay, using the properties of equality, what we're going to do is create two-column proofs. Okay, so the rest of your paper has these two-column proofs on it. Okay, the left side of a two-column proof, okay, we're going to call these the statements. Okay, so for our purposes today, for algebraic proofs, these are just going to be the steps of the equation. Right? On the right side, okay, or the right column, I'm going to list the reasons that justify each step. So today, what we're going to use to justify are all those properties that we just looked at. But once we start getting into more geometric proofs, we'll also use things that are called postulates, theorems, and also definitions. So when we're writing a two-column proof, okay, we will always be given some information. Okay? For today, the given information is just going to be the equation that we have to solve. Okay? So the first line of every proof that we write is just going to be whatever that given information is. Okay? So the first line is rewrite the equation, and then my reason is, well, that's what they gave us. Right? It's given. Now, what we want to look at is how did I get from one step to the next? So the equation I'm starting with is 4x minus 1 equals 27. What would be my first step to solve that equation? Add 1 to both sides, right? And we can write that in here. So we're adding 1 to both sides of the equation. So the step, or the reason, would be the addition property. If I'm adding the same thing to both sides, that's the addition property. Now what do I do to get from 4x equals 28 to x equals 7? Divide both sides by 4. So that would be the division property. Okay, so all we're doing here is solving equations, okay, that we already know how to solve. We're just justifying each step, okay, with some property that allows us to do that. Questions so far? All right, let's do another one together here. Let's take a look at number 2 together. So again, the first line is given to us. Okay, a over negative 6 plus 2 equals 5. So now, what do I do to get from step 1 to step 2? Subtract 2 from both sides, right? Minus 2, minus 2. So, a reason would be the subtraction property. Now, I've got a over negative 6 equals 3. What did I do from here to get a equals negative 18? Yeah, I multiplied, right? I would multiply both sides by negative 6. So that would be the multiplication property. Questions? Why don't you guys try number 3? See if you can come up with 3 missing reasons here for number 3.
So this was just a addition,
Yeah.
That's for number 2.
Yeah, we're just writing the reasons, okay, that justify each step. Right? What we did to get from here to here, what is our reason for this?
Yeah. So
So,
4 or 5.
for the last one on number 4. All right, let's take a look at number 3 here. Okay. So as you're going through this, okay, it's a good idea to write down the work that's happening, right? I mean, you don't have to, but to see what's actually happening, it might be a good idea. So we're given an equation. So my first line is given. The second line, what I did was distribute that -9 through. Okay, now I'm guessing some of you were tempted to put multiplication, okay, because we are actually multiplying. But those first 4, the addition property, subtraction, multiplication, division, those are only when I'm doing the same thing to both sides of the equation. Right here, all I'm doing is distributing this -9 through. So that would be the distributive property. Then, to get from line 2 to line 3, I would subtract 27 over. So that would be the subtraction property. And then to get from line 3 to line 4, I'm dividing both sides by -18. Okay. Questions? All right, why don't you guys try number 4 and try number 5 then. All right, go ahead and try 4 and 5. You could. I don't think you do on either of these though. So which line are you looking at?
Oh, yeah. Yeah. Well, so that's
I like it. You can sleep.
My guys are always cold.
Yeah.
what you consider
So you should be.
what did you say?
Well,
they didn't do it before. Usually you would.
Sorry. Are these ones right so far? Because I keep getting stuck on what this would be. But I don't know if it'd be like addition, subtraction.
well, so they moved the x's over to the right side, right? So if I want to move this 6x over here, I would have to subtract it from both sides, right? So that would be subtraction property. All right, let's take a look at 4 and 5 together here. Okay, I put number 4 up on the board already. So my first line is the given equation. Then to get from this line to this line, they subtracted the 6x over to the right side. So that would be subtraction property. Then they added 17 to both sides. That would be the addition property. Divided by 2, division property. And then all they did was switch things across the equal sign. So that's the symmetric property. So one thing to point out here, okay, whenever you're solving an equation, and you get to this line, you think, well, I'm done, right? We got x by itself. But technically, if you look at, scroll up a second, if you look at what they tell you to prove, it says prove x equals 12. Well, when we get to here, we proved that 12 equals x. That's not identical to what they asked us to prove. So we do actually need that one more line to flip things across the equal sign. Okay? It's a small technicality, okay, but to be proper. Okay, that's why they did this. Okay, they had a whole extra line to prove exactly what the problem told us to prove. Okay, not 12 equals x. We want x equals 12. Okay. Now, in number 5 here, there's something else that happens, okay, that some of you have recognized, right, that I want to go over. So we have a fairly long problem to start. Okay, so that's my given information. Then in the second line, they actually distribute twice, right? Distribute the -7 through over here and distribute the 6 over here. We can do both of those things at once. So that would just be the distributive property. So now, to get from line 2 to line 3, on the left side of the equation here, they just combined the -7x and the 4x. Okay? So I think a lot of you were tempted to put the addition property, okay? Because we're adding those two things together. But the addition property is only when I'm adding the same thing to both sides of an equation. So here, okay, we just combined like terms. So we could write that, okay? Whenever that shows up, we can just write combined like terms. Okay, so technically that is not the addition property. And if I'm just combining like terms on one side of the equation. Okay, so now go from line 3 to line 4. Let's see, what are we doing? They subtracted the 12x over to the left side here. Okay, and that's not a step that you would usually do. Right? Usually, we're conditioned to add the 3x over, so our x's stay positive. But instead, they subtracted the 12x over. Okay, so if we are following somebody else's work, we just have to see what they did. Okay, here they use the subtraction property. Then to go from line 4 to line 5, they added the 14 over. So that would be the addition property. And then finally, they divided both sides by -15 to get x by itself. So division property. So the question also came up, could we use the same property multiple times in the same proof? Yeah, absolutely. Right? You could subtract multiple times, you could add multiple times, right? The same property could show up more than once in the same proof. Okay? Any questions? Oh, we got plenty of time. All right, so let's flip over to the back. And on the back, we have to write the entire proof. Okay? So we have to solve the equation and justify it. Okay? I actually think this is easier because you're not trying to decipher somebody else's work. Okay, you're just solving the equation yourself and then writing your reasons on the other side. Okay, so let's do one of these together. So what should my first line always be? The equation, right? The given. So I'm just going to rewrite the equation for my first line, and then my reason is given. Okay, that's always the first line. So now, what would my first step to solve this equation have to be? Subtract the 1 over, right? So I'm going to show my work. I'm going to write this out. So I'll get 3x equals -15 then. What's that? So my reason is going to be subtraction property, right? I subtracted 1 from both sides. So now, what would be my next step? Divide both sides by 3. And we end up with x equals -5. So my reason, division property. And we're done, right? We proved what we want to prove. So sometimes we might not use all of the boxes that they give us. Well, I mean, it's already exactly what we want it to be. So if we flip it and make it negative 5 equals x, that actually wouldn't be what we want now. So, I mean, we could, there's not really anything we could do to add an extra line. I mean, that's it, right? We got to exactly where we want to be. We're done. Okay? So all we're doing here, okay, we're now solving the equation as well as justifying each step. Okay, so why don't you guys try number 2? And it's perfectly fine to show your work as you're going. Right? You don't have to make it look nice and neat like they did on the front. Okay? I mean, I still want to see each step, okay, but you can show your work as you're going through these. Yeah, if you guys are finished with 2, go ahead and try number 3 as well.
Like they started out.
So if you finished up 2 and 3, okay, take a look up here at my work for numbers 2 and 3. See how you did.
What's that 3 in front of that M on the 3?
Right here. So we get m over -3 equals -11. Yeah, so to get from there to there, I multiplied both sides by -3 to get m equals 33. So we were dividing, right? M divided by -3. So to undo division, multiply.
Why do you guys subtract?
Well, from here to here, right? I subtracted the 10 over to that side.
Yeah.
So, since this -1 is trapped in the numerator, we actually have to take care of the division first. So the first thing we would have to do would be multiply both sides by 2.
That's what I was going to do next, but now I know.
It really does not.
Okay, go ahead and move on to number 4. If you guys have finished up 2 and 3.
Should that be -33 though? Should that be -33?
Well, so we got a -11 times a -3. So negative times a negative will be positive.
Is this Korean homework?
I've got some problems. Whenever we have something like this, we'll get 30.
Wait, so you're saying we are not going to do all of this? I was beating over here for nothing.
What's up?
Or you can't multiply it by 2.
Yeah, that would have to be your first step. Right. Exactly. Yep.
Your final answer.
He's came, put it on there.
Gives you your final answer and you still. Usually if you just order a product, I don't want to know Gucci, Ratchet, Champions or something. What's your name? I had a pair of shakers. I know that. That's it. Just a basic white tee. Yeah, it's still. No, I swear that fucks like that. Yeah. Most of my shirts are like. Yeah, mine are between 10 and 20. I'll get a job. We're saving for college. Shoes, they sell for tires, and I grew out of them in 2 weeks. My dad will never buy tires. I know what you got one.